Let me just find out the one very important consequence of these two equations. I want to convert the system of first order equation into a wave equation or wave equation of second order. So how we do it? First of all, we take derivative of equation 1 with respect to t. So we get partial square p by partial t square plus k partial square u partial x partial t is equal to 0. This is equation number 3. Similarly, differentiate equation 2 with respect to x partial square u partial t partial x plus 1 over rho partial square p by partial x square is equal to 0. This is equation number 4. Then what we do, we have to eliminate this term from equation number 3 and the second term and the first term from the equation number 4. So what we do, we multiply equation 4 with k. K partial square u partial t by partial x, k over rho partial square p by partial x square is equal to 0. This is equation number 5. Now we subtract equation 3 and 5. Subtract equation 3 and 5. We get partial square p by partial t square plus k. K is over here compressibility, bulk modulus of compressibility. K partial square u partial x partial t plus minus, it should be minus k, this term, k partial square u partial t partial x minus k over rho partial square p by partial x square is equal to 0. Now you can see that the order of this mixed derivative is different than each other, and u is continuous. So according to calculus, that if we have continuous u and continuous partial derivative, then these both can be equal to each other. The order remains the same if the solution, or if the variable is continuous and their derivative is continuous, so on. So this term will be cancelled out. What we get at the end, partial square p by partial t square minus k over rho partial square p by partial x square is equal to 0. And solving it further, we get partial square p by partial t square is equal to k over rho partial square p by partial x square. As we know, the formula for speed of sound in the in the air is c is equal to k over rho under root with under root, and when we square on both sides, c square will be equal to k over rho. So this term, this equation will become partial square p by partial t square is equal to k over rho will become c square partial square p by partial x square. So you can see that this is a very famous equation, which is a wave equation. which is a wave equation. Probably you have seen the wave equation in your PDE partial differential equation course, or maybe while you study numerical methods for partial differential equation, then you must have seen a wave equation similar to that. Let me just write that equation for you. The wave equation that you study in partial differential equation course is partial square u by partial t square is equal to c square partial square u by partial x square. And you always wondered why there is a square over here. Now you know the reason why there is a square in this coefficient, since it is coming from this formula. In our case, this equation has a pressure over here, pressure wave over here, since we we were dealing with these system of first order equation, and these are acoustic equation. And we eliminated u from there, the derivative partial u by partial t, and we got this equation, which is a wave equation. We remember that if the coefficient matrix of 1 and 2, A has real eigenvalues, then we call such equation as hyperbolic. That is the definition when we study system of first order equation in finite volume method or CFT. Similarly, you know that from the partial differential equation theory, we have A partial square u by partial x square plus B partial square u partial x partial y plus C partial square u by partial y square. Then we have D partial u by partial x, so on. You have some terms over here. And according to that theory, when you have b square minus 4ac, b square minus 4ac, b square minus 4ac, it can be equal to 0, it can be greater than 0, it can be less than 0. So you characterize your partial differential equation as parabolic, elliptic, and hyperbolic. I'm not going to write this, what is b square minus 4ac, something like that. So here we can also say that this is hyperbolic equation. So that was all about the conversion from acoustic wave equation, system of first order equation, into the second order wave equation. Thank you for watching.